Hey everybody, welcome to part 2 of our Pioneer SX-1250 service video. I'm not calling it a full restoration because we weren't doing that. We were just kind of fixing what it needs, replacing the parts that we know are kind of, have been known to be problematic, and getting it back out to the owner. Now, this was going to be the final part in the series. This is going to be 2 parts. And you'll find out at the end of the video, we actually ran into an unexpected problem that we're going to have to troubleshoot and repair. And I thought that that would make a good video in and of itself, a separate one. So I'm going to end this video and then pick up with that in another part. So this may spill over into another part to finish it. There's a lot of interesting things I covered in this video. At least to me, they were interesting. And so I'm going to share them with you. There's one thing that, we were talking a little bit, and I originally told one of the viewers in the comment section that I was not going to post this. But I gave it a lot of thought, and you know what? I'm going to post it. I did a little clip. There seems to be kind of some discussion going on about the those transistors. Some of them, how they have those black leads, and I made mention that one of the some of those leads, the black coating is actually a coating on the lead and not tarnish, but that there is such a thing called black leg disease, and it is a physical tarnish that gets on like the silver plated leads. There's also some kind of brass copper leads that don't tarnish, but they also can have that paint, at least from my experience. This is what I was told. I read about it on forums. I've experienced it for myself, and I'm pretty sure that's what it is. But the point that I want to make, and this is why I'm actually starting this video with me talking to you, is that I never want anything on my channel to turn into an occasion for argument or for anger or anything like that. I'm fixing a stereo on a bench. You have to put it into perspective. Don't get uptight over things. If there's things that you disagree with or things that you don't understand or that I don't understand, and you're going to help me by commenting and we're going to talk back and forth, I welcome that, and that's the whole purpose we do this. But I never want this channel to turn into something where people are going to be offended or angered with one another or insult one another. I think you've known me long enough, any of you who've watched the 400 videos or so that I have on here, that I don't live that way. I don't like that sort of thing. This should be an occasion for us to talk about happy things in the world that we like. I mean, this is, listening to audio and working with electronics and doing things, a person's life doesn't depend on whether this works or not. I mean, it's sure important to some people. They have sentimental value. It's great technology. We enjoy the hobby of listening to good audio, but it should never be a reason for any of us to argue with one another or to dislike or hate one another over this. It's just not my thing. Do I need to say these things? No. I mean, whatever you think, I'm going to comment it though. That's what I think about this. So again, number one, when I say something on my channel, I never have the intention of insulting you or anyone, okay? We have fun, we make jokes, we laugh about it, I put on the grumpy face, that's great. It's all in good fun. Never ever do we want to hurt one another. Turn on the television and look at the news, and everything that's on there is crap. The only news that people put on these days is something negative to make us dislike one another and somehow take sides with them. Yeah, am I talking politics? Yeah, I guess this touches on that, and I don't like to do that on my channel, but it plays to the point that I'm making here, and that is, this is all about us having fun and working together and learning and sharing with one another. If we each have a different idea, we each have one idea. But if we share those ideas with one another, now we both have 2 ideas each, right? That's what this is all about. So Enough of my soapbox. I hope you enjoy this video. There's some cool things on here that I enjoyed, and I want to share them with you. And I welcome any comments and any corrections that you can make to me, or anything we can work together to learn together more. You know, this is my hobby. It's not an X-ray machine. It doesn't produce radiation. It's not something that I'm an expert on. So I'm doing this out of fun. So I definitely can be wrong, and have been many times. And some of you, thankfully, have corrected me, and I've learned from it. So that's it. Take care, everybody, and enjoy the video. Okay, picking up where we left off in the last video, we're going to work on these amplifier boards. You can see I have the first one removed from up there. There's 3 connectors in the front, 2 in the back, 2 screws, and it comes right out. These are the easiest boards to get out and to work on. Now, unfortunately, I do not have any of these 470 microfarad 80 volt capacitors. I would have to make a special order for them, and as I said, I'm not charging for this job, so I really don't want to do that. So what I'm going to do is I'm going to pull these caps, and I am going to test them very carefully. If they test good, I'm going to put them back in. These other 2 I will replace. This yellow one is most likely going to be okay. This orange one, again, these tend to go leaky. This one's probably going to be okay, but we'll test it as well. I don't really want to change it again. It's a very good audio grade capacitor. I'm not going to mess with it if I don't have to. Okay, I promised to show one of you viewers what these transistors look like with the paint on them. I had a comment that this transistor did not have painted leads, but rather it was corrosion. It was the black leg syndrome. And if you take a look very carefully at these, and you line the pins up, you notice they have a very straight paint coating across there. And the paint, I don't know if the light picks it up or not, but you can see the sheen that the paint has on it. And it's actually coated. And you can see underneath it, the leads are the kind of the gold coppery colored leads. You can see that center one because I cut that off above the soldering, where the solder was, because of, being able to get it out of the board more easily. And this was an attempt on some of the transistors out there to keep them from tarnishing or having the black leg syndrome, which still didn't work, because I think it really wasn't about the tarnish on these as much as the bonding wires would fail in them inside. So these leads have a even tinier wire attached to them that in turn attaches to the silicon on there, to the die inside inside this case. And I just wanted to show that, because don't mistake that for tarnish. That is not tarnish. Okay. If I find one that actually has tarnish on it, I will show it to you. But looking on these boards, you can see, for instance, here's an example. Let me see if I can get this light on here. Do you see this one down here? See how like the one leg is darker than the other on this? This is one of those thermistors. So that one, I don't know if the camera's actually getting onto it properly, but this component here, that has a little bit of tarnish on the right leg, and the left leg is just starting to get the tarnish. See it? That's the difference. And if you try to scrape it, you'll see it comes right off. You barely even touch it. See that? Whereas this one here has the paint. No, this one does not have the paint. See how this one's like kind of dark and matte colored? This is a 2SC 869. And look, I just barely touched this, even like with my fingernail. So this one has it. And you can see it rubs right off with my fingernail. See it? Whereas this one doesn't really do that, see? It doesn't come off. So that's the difference. Well, we're talking about old transistors. This is another interesting one. There's a couple different kinds. This one's a PNP, and it's a 2N3644. And its complement would be the 2N3569. And my cousin, he worked at Lafayette Radio Electronics in the early 70s, and he worked at Picker X-Ray later on in the later 70s. And I forget where he got these from, but he had a whole huge box of each of them. And he gave me a handful of each a long time ago, you know, back in the 70s. And it's strange because these things have moved with me from, you know, as I moved from my home, you know, with my parents and everything. They sat out in storage sheds for, you know, for years, with unheated, you know, in the damp and cold. And these gold pins, if you look at them, they have never tarnished. And they're similar to those pins on, where was that other transistor here? They're similar in material if you really look carefully. Let me see where I'm at here. You can see how they're kind of gold on these ones. And they don't seem to have the tarnish, but the reason that it's interesting is these are very high failure transistors, these dome-topped ones, the 3569 and 3644s. I had a lot of problems with these. I built a lot of little projects, you know, when I was learning. And these tend to fail. They were used a lot in some of the early X-ray machines as well for small signal, like logic switching and things. And they always tended to have problems. So I'm wondering, you know, you see how these are, I've never seen these tarnish, ever. But yet they seem to do the same thing as the ones that so-called have the creeping doom, the tarnish problem. So again, I wonder if it's just not so much the tarnish. I mean, I guess in some instances it must be. But I wonder if also it's just the way these things are made. They were, you know, some of these early production silicon transistors just didn't work, you know, didn't hold up as well as some of the others. And I kind of cashed that off to their age. But anyway, I just thought that'd be interesting to see. Now, another very, very interesting thing was a comment that a viewer made about the relay. He was 110% right. So this is the original relay out of the amp, and it's an IDEC. It actually says DEC, but if you want to look them up today, it's IDEC, IDEC. And it's a type MS4U, which they don't make these anymore. They've switched over to the type RY series, I believe. And you can see how tiny the contacts are on them. And if you look at the, and I have the cover on crooked, so it's pressed in right now. But anyway, if you look at the data sheet for the RY series, which is the same as this, you can see that the contacts are only rated at 30 volts DC. They're only good for 3 amps into a resistive load and 1.5 amps into an inductive load, if that makes sense. And then when you look at the UL ratings, they're a little bit higher. They're rated at 5 amps. And that would be what Underwriters Laboratory says that they're spec'd to, you know, to handle, not on a regular basis, but for their normal, you know, 200,000 cycle rating, they're not to exceed 3 amps per contact and 1.5 amps into an inductive load per contact. So if you double those up, technically, while they're together, between the two of them, you can drive a 3 amp inductive load through it. Now, the amount of current that these contacts can handle when they're together versus the amount of current they can switch, in other words, turning on and turning off, is different. Usually the switching current is lower than the actual closed contact current. So you have to keep these things in mind. And, well, if you do the math, into an 8 ohm load, 160 watt amp is pushing towards almost 5 amps of current, and of course that's an inductive load, into that 8 ohm speaker. Now that can change and fluctuate because it's an inductive load, right? It's reactive. It's not DC resistive. And long story short, this amplifier can exceed the rated current of these contacts even when you double them up. Which, why would they do that? Well, first of all, this is the same relay they use in their smaller amps. So I think they just used what they had. But when you want to keep in these little miniature ice cube relays, that's kind of the limit that you get. And if you look at them, this one doesn't give you much information, but if you go to the Omron, this is the replacement for this. It's the MY4, and just the standard MY4 relay, the 4 contact, it has the same exact specs as this. It's only good for 3 amps into a DC resistive load and 1.5 into a inductive load. And you could look up the sheet for the MY4. But if you look, the UL rating is 5 amps, just like on this. Now, you cannot switch that kind of current with these, but you can pass that kind of current when they're closed, okay? But even at that, we're still exceeding the contact rating of this relay. So how do they get away with it? Well, there's a couple things. Number one, they're betting on the fact that you're not going to run this amp at 160 watts continuous into a load and exceed this for a long period of time. Okay, that's number one. Because as you increase the current through those contacts, even though there's a tiny amount of resistance, those contacts will heat up. As they heat up, they'll begin to tarnish and to fail. Secondly, this relay was never really meant to switch or unswitch current. Now, I know what you're going to say when I said that. Well, Tony, if the amp's overloading, it's going to break, the connection to the speakers while they're conducting. And that is absolutely true. But what they're betting on is that only happens in an emergency. If you overload the amplifier, if a output transistor or a driver transistor or something shorts, putting a DC offset onto the speaker terminals, that is the only time where it is actually going to break the current. Okay? That's how this is supposed to work. The thing that will kill one of these, again, and I sound like a broken record, but when you turn the amp on with the volume turned up loud, and those relay contacts close into that speaker load, you will actually cause an arc, and that will cause premature failure of these contacts. You will not get 200,000 cycles out of them. And also, if you run this amp very hard, or if you drive a 4 ohm load, right? As soon as you go down to a 4 ohm load, your current goes way up, and you're way exceeding these relay contacts. So again, if you drive the amp really, really hard, you will exceed the rating of these contacts, and they will fail. And that's just an Achilles heel of this amplifier, and the only way to fix it, they don't really make a relay that will handle that. You can go to something like this, which I have these two, and these are single contacts, and they're rated at double the current. You can see it says 10 amps, which is the UL rating, okay? And they're good at about 5 to 7 amps into a into a resistive load, and about, again, half of that into a inductive load. So even these, these single contacts will still be, you'll be exceeding their rating just as you will with 2 contacts together. So this really doesn't buy you anything to use these. And like I said, the bifurcated contacts are a little bit better. They have but they still have a very similar rating to this. I'll show you one of those too. So this is a double pole relay. It's the same relay, and it will drop in replacement for this one. But if you notice, it's split, and it's because there are 2 little contacts going onto this contact in here. I don't know if you could see it, but it's kind of, there's two of them, and one will always come in before the other, and we explained that in the previous video about this. Okay, whereas this just has a single contact coming in and out. So the idea of this is if it does switch the current, you might tarnish up one of the contacts sooner, but the other one will have lower resistance and take that up as it closes, and hopefully it will last a little bit longer. But these really have to do with the way that it switches the current in and out and the way it conducts the current, which one you would use. But, you know, stereo manufacturers have used all of these, trying different things, but these little relays are just too small for switching a big amplifier like this. And that's why when you look at the ADCOMs and some of the huge amplifiers that are out there, they don't even use a speaker relay. They just hope that that the amp doesn't short out and grenade your speakers. But that's the trade-off you're going to have. I guess you could use the bigger case relays with the bigger contacts, but for some reason they've never done that. And I'm not in the mood to modify this thing. I want to just keep it the same. But long story short, this is the same rating as the original. And yes, according to what the one viewer said in the comments, he's absolutely right. It's underrated. And that's the way it is. Okay, the board's all back together. I put these two back in because, well, they tested perfectly, number one. Number two, I do not have any 470 microfarad at 80 volt. I have some 1000 at 100, but that's too much capacitance for this board, and they're a little bit too tall, so they'd have to fold over. It's just not necessary. Again, if they fail, you know, Joe can take it back to me. I can swap them out real quick, and it's no harm, no foul. As for the tarnish on this one, I just took a swab and some alcohol and it rubbed right off. Although I don't think that really hurts anything on these ones. I don't think it's gonna, just looks better. Anyway, let's put it together and let's make sure everything works. And if it does, we'll move on to the next channel. Okay, I also forgot to mention, and I don't know if you can see it now, but right up in here is the DC balance pot. And I replaced that with a 10 turn because it's just a lot easier to get your DC offset to 0 volts with a 10 turn pot. Now the one over here for the bias, I just left it in there. It was in good condition. And, you know, a single turn pot, it's pretty easy to get your bias where you need it with that. So I didn't mess around with that one. So, all right, let's test it out. Okay, if you want to follow the procedure, you will need to remove the jumpers from the pre-out to the power in. And you'll need to, in the power amp in, you'll need to just put a dummy load over there, or a kind of a terminator. And they want a 5.1K resistor. So I have pretty much all of the Pioneer gear uses this, so you know, you might want to make one of these up. I use these little RCA with the terminals on them, which is really handy. And I just took this one, and there should be another one in here with the 5.1K resistors, and we'll put those in and just plug them in on the back there, and we will be ready to do our alignment. Okay, and this is how it looks when you plug it in there. You can also just get a plain RCA plug like they did and solder it in there. It'll work just the same. I like these terminals because if I want to switch out a different resistor for a different type of amplifier or something, I can. Okay, I have the meter connected between pin 9, which is the second pin over from the right, and ground. And I turned the amp on. It's been on for about 2 or 3 minutes, and you can see we want 0 volts. And I just kind of measured the old pot and set that new 10 turn one to the same resistance, and look how close it is. So let's go in there and see if we can bring it down to 0 volts. I mean, this is something would be very hard to get it much closer than this, you know, without a 10 turn pot. So first of all, let me get up on here. Okay, wrong way. And you have to give it a second. You have to turn it and then just wait a second and then turn it again. You just have to keep going back and forth until you get it. And you can see I'm getting really close now. I think we'll leave that alone. What do you think? Okay. Get it down into microvolts. I think you're good. Okay, now to check the bias, we're going to move our meter probes and we're going to go between pin 7 and pin 19, which are the two outside pins. So we're going to move this one over here. I'm going to switch out to hook probe here for this. And I'm going to put, and you're not seeing a darn thing I'm doing, are you? I'll put this one over here. And they're saying we want somewhere around, what does it say? It says 100 millivolts, and it's about half right now. We're only at about 47 millivolts. See that? So let's see if I can get everything in there. 47. I don't think we need that light. You can probably see better if I do it that way. All right. And so we're just going to take this. We're just going to ever so slightly move it. And I'm probably going to only go about 75 millivolts or so, or 80, simply because this is going to drift around and so forth. And as long as the transistors are, you know, better matched than the worst case scenario that they've planned on, the amp can run a little bit cooler and we still aren't going to get any kind of you know, crossover distortion. So that's good. We're just going to leave it. I'm going to let it cook for about 15 minutes. If everything looks good, then we'll go ahead and we'll replace the components on the other amplifier board and do the same thing to it, and we'll be good to go. Well, we're going to use the leader scope over here because this thing's so huge it blocks the view for any other scope I have on the bench. Right now, I have this scope set to the highest sensitivity, and I'm going to look right now for crossover distortion. We have the bias set, and I've set it lower than the factory recommends. And we just want, and I have the minus 20 dB muting switched on, so that we can adjust the volume in to very low levels. Because what we want to look for is crossover distortion at very low volume levels. So I have a 1 kilohertz signal going into the auxiliary jacks, and I'm hooked up to the dummy load. And if we go in here, we can see, even though it's jittery because I'm on 5 millivolts per division on the scope, we have a very clean waveform. And if we had any kind of crossover distortion, you would see it right here at the notch point, right at the zero crossing. And obviously we're not getting that. So now what I'm going to do is I'm going to turn this down. I'm going to turn the muting off back to normal. And we're going to set the scope sensitivity way up now, obviously. Okay, what I'm going to do now is I have the scope set, and let's see if I can reach around here. And I'm going to put these two traces for left and right channel right on top of one another. And we're just going to make sure everything tracks together. And now I'm on 10 volts per division, so each graticule will be 10 volts. So let's see what we get here. So there's 50 volts RMS, or 50 volts peak, and 100 volts peak to peak. Okay, and if we do the math, 50 volts times 0.707 equals 35 volts RMS, and we square that and divide it by 8 ohms. That's 156 watts per channel right there, and you know, full scale, and it still wanted more. So I could probably go higher, I would say. So let's see if I can move this again and see. Just, I'm not going to do this for very long because I have the amp on its side, so the one heatsink is sitting underneath everything. But we're just going to go real quick to see where we are. And there's nice even clipping, so that looks good. So the amp is working right now. So we've got that done, and everything looks good amplifier wise. We'll do all of our other testing when the amplifier's put back together, when everything's finished. But I think we can move on now to the tuner section and to the phono stage and make sure they're all good, and then we can button this thing up and do some tests on it. I've removed the cover, the shield cover, from the phono stage and removed the 4 mounting screws from the phono stage board. And I'm just going to replace a couple of these capacitors on here. And I'm going to replace these two SA-726s. They have the orange dots on them. I don't know if you could see that. And that means they're a matched pair. They actually are a specific gain range. And what we're going to do is we're going to take a couple of transistors and match them. And we're going to replace those. The rest of them on this board should be okay, as far as I can see. And we'll replace a couple of capacitors on the board, and it should be ready to go. There's not really a whole lot we're going to have to do to this. We really don't want to interrupt it or, you know, change it anyway, any more than we have to. So let me get some transistors and some capacitors, and we'll get this replaced. Okay, the original 2SA-726, if you look very carefully, the last letter on there is a G. And this is going to have like a gain range in the 400s. And if you notice, there is a orange dot on top of that. And they're signifying that that's in that 400 gain range. So what I'm going to use, and it's going to have probably a different pin out, I think, but where I'm going to use a KSA992 FB series. That's going to be in that same 400 gain range roughly. And you can measure that on a little transistor tester and so forth. But what you'll find is these are pretty tight. There's 4 different gain ranges, or 4 or 5 different gain ranges you can buy these in. And if you get the correct gain range, it'll match this. You almost don't even have to test them or match them in a matcher because they're so closely matched. I still like to test them just in case, using either the matching jig or just using one of those little transistor testers just to check the gain and the VBE and make sure they're the same. But for the most part, once you do that, these are going to be, if you pull these off of the same tape, they're going to be very, very similar, almost identical within that range. And so that's what we're going to use. Now again, the only thing, these are emitter collector base, and I think these ones are a little bit different, so I don't think these are emitter collector base. So I'm going to hook this up and I'm going to check it. And the gain should be in that 400 range. Let's see. I don't think this is a drop. They're going to have to reorient the transistor. Okay. And so the red is, yeah, it's base collector emitter. So it's BCE instead of ECB. You see that? And yeah, and look at the gain. It's 426. So it's always going to be in the 400s if the transistor is good. This transistor is good, but we don't know if it has shot noise or not, nor do we know if it'll develop it. Like I said, way too many times, especially on the Pioneer gear from this era, I have seen this. And I don't do this for a living, so I only do this for a hobby. And even in just the sample of these that I've worked on, I've seen a lot of these be bad. So I just replace them as force of habit, and I can tell you there are all kind of forums and things out there where people talk about these. So good idea to do. But anyway, if you don't have a transistor matcher, following the, picking a gain ranged transistor like this, like these FB series KSA 992s, will ensure that you're pretty darn close, and 9 times out of 10, if you just pull them off the tape, they'll be okay. All right. Now I went the extra mile and I checked them, and this pair is almost exact, both with VBE and with gain HFE. Same thing with this pair. So this pair will go on the other channel. But anyway, let me get these out and we'll get them replaced. And here are the components we replaced on the equalizer board / phono stage board, whatever you want to call it. And there is the finished product, and that's ready to go back together and we can test it. So everything's good there. Got our new KSA 992s in there, and I think everything's going to be good for a long time to come now. I have the shield and everything put back together on the phono stage. Now what we're going to do is we're going to do the 330 and 300 test to verify, just in a general way, that the phono stage is doing what it's supposed to do. And what is the 330, 300, you may ask? Well, at 20 hertz, 3 millivolts signal, and 1 kilohertz, 30 millivolts signal, and 20 kilohertz at 300 millivolts signal, they should all give an output at the record out jacks of the same amplitude, if that makes sense. We're basically feeding a signal in that will give you the same amplitude out at that frequency. If it tracks, then it means that the RIAA curve on this is generally working. Now, remember, the curve is called just that. It's not a slope, it's a curve. So it does have a little bit of a kind of a, I don't know if you'd call it a hysteresis, but it's a logarithmic curve that kind of S-curves a little bit. But it is generally, at those 3 intersecting points, if your filter is working right, it should return that output. So a picture's worth 1,000 words. So what I have here is, if you look in the back of the receiver, I'm going into the Phono 1 jack with my signal generator. Okay, I'm putting the same signal in both the right and the left channel. I'm coming out of the record jacks and going up into my oscilloscope here. Okay, now the signal generator that I'm using is capable of very, very accurate amplitudes. So as long as, you know, it's set up for high impedance right now, and that is a relatively high impedance input. So if I put at 20 hertz, 3 millivolts, I'm going to measure what the output is. Okay, so that's what's in there right now. And if we look at our oscilloscope, our oscilloscope, there it is. You can see, or maybe you can see, maybe you can't see, maybe it won't focus. But you can see there's our amplitude. And I can turn that down a little bit because that's pretty high, huh? Turn that a little bit down. Okay, so there's 20 hertz, and you can see that it's about 1, 2, 3, 4, 5 gradicules. So it's putting out almost a 500 millivolt peak-to-peak output with a 3 millivolt input signal at 20 kilohertz. Now if I change my frequency to 1 kilohertz and I change my amplitude to 30 millivolts, it should be the same amplitude, and you can see it pretty much is. There you go. And I have the 2 channels superimposed over top of one another so you can see how close they track to one another. And you can see once again 1, 2, 3, 4, 5, and a little bit over. So it's just slightly higher gain there, but pretty daggone close. Okay. Now if I go to 20 kilohertz and 300 millivolts RMS, again, You can see 1, 2, 3, 4, 5, and a wee little bit over. So there's a tiny little bit of extra roll-off at 20 hertz, and I would expect that because, once again, 20 hertz is kind of the cutoff point, and a lot of turntables, you know, don't really go that low anyway, but they can. And that actually is going to help with rumble as well, subsonics and so forth. So basically, what this is telling us is that the RIAA, or the equalization amplifier in there, is working properly, and all the filters are working properly. Now we can do an actual curve, you know, we can do a Bode plot using the frequency analysis program on the scope over there, but not necessary. Pretty much if it's going to hit these 3 points like that, you can be fairly confident that your phono stage is tracking properly. Now, if you're really into this audiophile stuff and you have a billion-dollar turntable and all that, well, of course, you're going to want to plot it out. But those 3 points for the average phono stage, quick and dirty test, 330, 300 millivolts, 20 hertz, 1 kilohertz, 20 kilohertz. Remember that, and you're good to go. Okay, moving on to the tuner. I'm using my SG-80 stereo signal generator, and I'm putting a fairly strong signal of about 150 microvolts into the antenna jack. You can see down there where it's connected, and I'm looking at the record outs, and I'm set to 98.1 megahertz, and you can see no matter where I go through tuning this, I can never get it to tune in. See that? It just looks terrible. I can't get a waveform. Now I'm getting a stereo beacon. I can get it to show stereo, but the tuning centering is off, and all kinds of problems here. And you can see, you see that zigzaggy on there? It's apparently doesn't look like it's filtering out the 19 kilohertz pilot tone, or the 19 kilohertz pilot tone adjustment, the pilot adjust is not correct. So there is definitely either a failed component in here or a really serious alignment problem, because no matter what we do, we can't get it to tune in properly. So we're going to have to look into this and find out why is the tuner doing this. Now, since this looks like it's going to be a very interesting troubleshooting opportunity for us, I'm going to end this part right here. Now, I was going to just, if it tested out perfect, we were going to do our normal tests on the amplifier, and we were going to close out this series and we were done. But since we have an actual problem now, I'm going to end this part right here. I'm going to get it edited and posted, and we're going to do a separate part on troubleshooting and aligning the FM tuner, because this looks like it might be a little bit interesting, and we can kind of walk through the sections of the tuner and how to troubleshoot it, and then how to get the alignment back in. So, hate to leave it a cliffhanger, but I think that's what we're going to do. And until then, I wish you all peace, joy, happiness, and good health in your lives. And we'll see you again real soon. Take care, everybody. Bye-bye.